I'd like to begin with a question. What is language? Now, we linguists define language as a set of rules that governs any communicative system, whether that system's sign language or spoken language. Now, language is one of the most quintessential qualities we have as human beings. This basically makes us who we are. Yet we know very little about how the brain processes this. Arguably, language is one of the most difficult things to study in science. For centuries, we've tried to understand how the brain acquires and uses language, yet we know very little of how this is done. For me, as a child, I grew up in a multilingual home with friends and family. I was just fascinated by the fact that at one topic conversation, multiple languages can be switched in and out. It amazed me. Then I go to college, and someone tells me, "Hey, Mike, you know you could study that phenomenon?" I was hooked. I knew that's what I wanted to do with my whole life, study language. So at this point, you're probably asking yourself, great, but rats don't speak, Mike. And you're right, they don't talk, but they sing, and they sing real well. Now what you see here is a sonogram. Now this is a pictorial representation of an acoustic signal. On the left, y-axis, kilohertz and frequency. On the bottom, x-axis, time in milliseconds. So what you see, think of it as a heat map, where warmer colors such as red are indicative of more acoustic power, cooler colors such as blue are indicative of soft acoustic power. Now, the rat is different than we are. It prefers to vocalize in an ultrasonic range outside of our normal hearing. So what we have to do is we have to use computer technology to convert that to our normal hearing range. And when we convert that signal, this is what a rat says. That's a beautiful sound. I listen to these things on headphones, and I'm glad you could hear that. It's just amazing. Work with the rat, we now know that there's 3 large distinct classifications in their communication repertoire. The first one is the 22 kilohertz vocalization. Now what's unique about this type of call is that it's indicative of the animal when it's not happy. As you can see from the sonogram, it's very long in duration, carries a lot of acoustic power, and it doesn't have frequency modulation, no contours to its frequency. So when we hear a rat or we do something to a rat, it makes it unhappy, it sounds like this. Now the second large class of vocalizations are the 50 kilohertz calls. Now these are different from the 22 in that the 50 kilohertz vocalizations are reflective of when the rat's happy. The other thing you'll know about this is that they're shorter in duration compared to the 22 kilohertz vocalization, and they have frequency contours. Now there's a lot of different ways you can make a rat happy. In the lab, what we do when we're training them, we give them Fruit Loops. They love sugar, just like any kid. Another way that we reward our rats for doing what we ask them to do is we'll roll them on their backs, and we'll tickle their little bellies. When you tickle their belly, a rat sounds like this. That's telling you the rat's happy. Now the third class of call is the 40 kilohertz vocalization. Now this is unique to the baby rat, or rat pups as we call them. Now when a rat's born, it's deaf, blind, and it doesn't have fur, so it has trouble regulating its temperature. So if it wanders away from the nest, it's developed a surefire mechanism that the mother will understand and bring it back to the safety of the nest. And it sounds like this. It's almost as if that rat's saying, "Mom, Mom, Mom." Those of you out there with children, especially you mothers, know immediately what response this gets. Now we are just beginning to really appreciate the communicative system of these rats. There's several different call types, and we know they have meaning and they use them interchangeably with each other. It won't be long before we have the Rosetta Stone and better understand this. So the science is coming. Now for me, I'm interested in human language. And so we know from humans that there's gender differences. There's subtle gender differences. The way the girls speak, the way the boys speak, men and women. So I was interested with the question of, do rats have these subtle differences? So going back to that 40 kilohertz vocalization, that mom call, if you will, we just simply recorded rats. And as you can see from the sonogram, the male rats vocalize differently than the female rats. So being a neuroscientist, it's inevitable we're going to ask the question, is there a gene responsible for this? Well, I can tell you this. There's no one single gene responsible for language, but there is a gene that's really important, and that's FOXP2. So what we know of FOXP2 comes from a family in England. What's interesting about this family in England is that there are certain members of this family that have a mutation in their FOXP2. That mutation causes problems, and those problems are language deficits and cognitive deficits. So I was interested to ask the question, well, if you have a mutation in FOXP2, it impacts the vocalizations, speech in humans, I wonder if we altered FOXP2 in the rats if we'd see the same thing. So we did just that. We targeted FOXP2, we altered FOXP2 in these male and female rats. And what we found, as you recall from that earlier sonogram, is in the normal developing case, males vocalize differently than females. But when we inhibited FOXP2 and gave it to the males and females, what we found is we were able to reverse that difference in their vocal calls. So we were able to make a male sound like a female and a female sound like a male. As I mentioned to you before, that mom, that 40 kilohertz vocalization between the pup and the mother is very powerful. It's a communicative unit. They're exchanging informations. So what we asked is, does changing that vocal call by altering FOXP2 change the message that's being delivered from those pups to the mom, thereby changing her behavior and the way she interacts with these pups? So you'll notice in this picture here on the right-hand side, this is the cage of the rat. On the right-hand side is where she built her nest. What we simply did was remove the pups, mark them for identification, and place them in the opposite end of the cage, and recorded the order of retrieval of the mother picking up the pups, taking them back to the nest. That behavior looks like this. Now, the thing you'll notice, other than its speed, is the mother just doesn't pick up the first pup she comes to. There's something drawing her attention to prefer to pick up other pups over other ones. In fact, she'll step over some, pick up some, and drop them to go retrieve another pup. What we found is that in the normal condition, the mother would prefer to retrieve a male before a female. But when we altered FOXP2, what we found is that the female, remember that when we altered FOXP2, we switched the vocalizations. So what we found in this type of behavior is that the mother, when she retrieved a male who was given the inhibitor to FOXP2, that mother treated that male not like a normal developing male, but in fact like a female, and retrieved him no different. Likewise, with a female who was given the inhibitor to FOXP2, who now sounds like a male, that female was retrieved no different from the normal developing male. So effectively, altering FOXP2 changed the vocal repertoire of these pups, that changed the signal from the pups to the mother, thereby changing the way she interacted with her pups, changing the behavior. Now, the thing you'll notice about all these disorders is, one, they're all neurodevelopmental in origin. Two, they have a higher prevalence rate to affect boys over girls. And three, one of the core symptomologies of these disorders is a language deficit. So I'm the luckiest person in the world, I think. I get to study at Virginia Tech. I'm part of a great program. I have great colleagues, probably the best program director you can imagine. They let me do this stuff. They motivate me. I'm inspired. I'm that goofy little kid that still loves language. And it's really amazing to me that I can study this, and my goal is to help contribute to science so I can better understand language, contribute to science, thereby giving people with language deficits a voice. And with that, I thank you for your time.